Hey everyone, welcome to CSM 61B mock final. On this question 1, we'll be going over time for bits, which deals with bitwise operations. So kind of going over the first one, says what does the following expression test? N bitwise and n minus 1 equal to 0. Now, I think the best way to approach this is by going over a few examples. So let's say for example 6, bitwise and with 5, because that's 6 minus 1. As you see here, we end up getting a number that is not equivalent to 0. Let's go over another example, such as 8. Now in this scenario, when we bitwise AND it with 8 minus 1, 7, in this case, we do get a number that's equal to 0. Something that we realize here is that when we do bitwise AND n with n minus 1, we only have all the bits flipped when there's only one bit here that is set to 1. So we want all bits to flip, or at least there not be two 1s that are being ANDed together, so that we can get all 0s in the end. So in this case here, when it says what does the following expression test, and bitwise and n minus 1, it is testing for whether or not a number is the power of 2. And as we know here, if only one bit is flipped, such as this number 8, then we know that this is a power of 2. Going over this next problem, question 1.2, count ones. Write a function that counts the number of 1 bits in an integer. So a simple approach to this would be to take a number and bitwise AND it by 1. The reason being is because we can go ahead and look at this portion. We bitwise AND it by 1, the outcome in this at the end would also be 1. So we can go ahead and do this repeatedly, going down this number. And the way we can do this is by shifting the number to the right. So how exactly would we code this out? Well, something to keep track of is that an integer has 32 bits. And we also got to keep count looping through the number every time we go down this way. So let's go ahead and do that. We're going to go ahead and start off with a counts variable equal to 0 and a for loop. For int I equals 0, while I is less than 32, because an integer is 32 bits long, and then we iterate I. If n and 1 is equal to 1, such as we see here, where we take this number and AND it by 1, and as you can see, in the end, we could get 1, then we're going to go ahead and add 1 to count. And then afterwards, we go ahead and shift this number by 1. So we're going to take this portion and just shift this part over and repeat the process by bitwise ANDing it by 1. Now in the end, we're simply going to return count. For this last question, 1.3, it says write an expression equivalent to x times 27 without using multiplication, division, or mod. Now, the simplest approach to this would be to take the number 1, for example, and try to turn this number into 27, which is so how exactly can we get the number 1 and turn it into the number 27? The best approach would be to use left shifts multiple times. And how exactly we can do it? So we're going to take this number 1. As you can see, we have 4 spots we need to fill in right here at 16, 8, 2, and 1 to make it add up to 27. We can take this number 1 and do 4 different left shifts and add them up. So for example, we can first left shift number 1 by 4 to get 16. Then we could take the number 1 and left shift it by 3 to get 8. Now we can repeat this process to get 2. And then just add itself as well. So once we have these 4 different left shifts, we can go ahead and add it up to the number that we want, being 27. the way we write this in code is the exact same way that we did it here. We take the number 1 and left shift it 4 times and simply add up the result that we have here. Thank you.